In question 21, part A, we start off with the simultaneous equations question. The two equations are y plus 2x equals 5 and 2x squared minus 3x minus y equals 16. Since this is a quadratic, we will need to use the substitution method. So I'm going to have to rearrange this first equation so that I can substitute it. The easiest way is by subtracting 2x from both sides. I'm now able to substitute where we have y here for 5 minus 2x. Using brackets can avoid missing the double negative that we would have when we expand this. So expanding, I'm now going to collect the like terms. Minus 3 plus 2 is minus 1. And I'm also going to bring this 16 across by subtracting 16 from both sides. Minus 5, subtract another 16 is minus 21, and that's now equal to 0. I need to factorise this, and I believe I can do it into paired brackets. 2 times minus 21 is minus 42. I need to find two numbers that multiply to give this and add up to give minus 1. 6 times minus 7 is minus 42, and 6 plus minus 7 is minus 1. I'm going to pair the 6 with the 2x squared and the 7 with the minus 21 because they share a factor of 7. Taking out common factors here, and taking out common factors here, it's worth noting that minus 21 divided by minus 7 is positive 3. However, you can see from the fact that these two match that we know we're on the right track. And there's my factorisation. This leads to solutions for x and we're halfway to getting our complete solution because we have the x values. What I need to do now is use these x values to find the corresponding y values. I'm going to substitute this x value into this equation here. This makes 7. 5 minus 7 is minus 2. And taking the other x value and substituting into the same equation again, this will make positive 6, giving me a total of 11. So my solutions are x is 7 over 2, y is minus 2, x is minus 3, and y is 11. In part B, we are given the inequality 2x squared minus 3x minus 16 is greater than 5 minus 2x. And we are asked, it says hence or otherwise, find the set of values of x for which this is true. I'm going to start by rearranging this. I'm going to subtract 5, I'm going to add 2x. Adding 2x will give me minus x. Subtracting 5 will give me 21. Now, I've already factorised and solved this as an equation, which will allow me to find the roots of the inequality. This is a positive quadratic, and we know that there are two solutions, and we found those in the previous part. So I know it crosses the x-axis there. Since it is greater than 0, I'm looking at the positive y values, and the corresponding parts of the curve are the parts above the axis on the outside, given by the inequalities. X is greater than 7/2 and x is less than -3. Writing this in set notation, my answer is and that's my final answer in set notation.